All right, let's begin. To my Twitch viewers, sorry I missed the past few streams. Wednesday, I was feeling under the weather, decided to just take the day, away from stuff and rest. And then Friday, work was so hectic and busy that I just was exhausted by the time I got home and just decided not to stream. So I apologize for that. And to my YouTube viewers, I do my best to keep a upload schedule going, to constantly upload when I can, at least on the days that I stream. So there will be days that I miss uploading just because life happens and all that wonderful stuff. So the last video we did a lot of the coding. We got the gantry to move back and forth. It basically hits the limit switch, moves the other direction, hits the limit switch. We have basically some safety checks in place to catch any potential problems or failures with the system, or to do their best at doing so. So now we want to kind of code in some status information and get some status stuff in here, get the cycle count going, and a few other things. So I've been kind of pondering how I want to go about this, because the status information, for one thing, I want to be able to control the LED and to look at like a status flag or something, and figure out how to flash the LED based off of the information in a status flag, or whatever. Because we want to store, some faults, just basically that there's a failure, or there's an issue, something. So I've been trying to figure out how I want to go about this, because we could turn it to a header source setup to where it could be modular and just dropped in any potential project, but it might require a ton of customization per project. So I might just incorporate that into the main code. And then the cycle counts, I might actually incorporate into the same code, into the base. But I'm not 100% sure if I want to do that, because the cycle counts, I mean, it could be more universal. Yeah, this is where kind of thinking of programming structure and how we want to do things. So if we throw it in the main code, so let's show. So if I throw it into the main code, that just kind of adds more stuff here. And then it starts mixing stuff into this. And then we have to work on diagnosing it and troubleshooting it. But if it's over here in its own source and header file, it's isolated and it's standalone. And yeah, it might take a lot of customization to drop into another application or something for another purpose, but it might be easier to do so because it is a source and header file standalone, and you just have to incorporate the header file, do an include, and then go from there. So what we might do is we might go ahead and do that for the status and the cycle count. Because the cycle count, I want to be able to incorporate the non-volatile memory storage. That way it will persist the cycle count through the entirety. Even if we power it down and have to resume, we can read the non-volatile storage and then resume the cycle count every so often, update the non-volatile storage. We'll have to kind of figure out a time frame for that. So, because I don't want to be updating I don't know if updating the non-volatile storage for every increment will hurt it. So while I'm thinking about stuff, let me All right, so let's see, about 10,000 cycles per memory store. So what we could do is set it up so if the counter is divisible by like 20 or something, or 10 or something, um, then go ahead and write. That way we could reduce the amount of write cycles to the non-volatile storage. But first, let's go ahead and kind of punch in the status. Because for one thing, I want to get that red LED out of the way and kind of start sussing out some of those things. So we're going to go under components. We're going to new folder. We're just going to call it system status. Yes, I'm going to paste those in there because what we're going to do, rename it. No, don't hit delete. System status. All right. All right, so okay, driver. Don't know if you really need the driver, but I'll just leave it alone because there's no reason to break it. All right, so here, system status. Okay. System status. All right. System status.h. Yeah, we need a GPIO. Let's get rid of these guys because yeah, we'll need GPIO because we're going to be controlling the LED. Let's save this. Header file. For status. All right. Don't really care. Okay. All right. So, what do we need to All right, let's get rid of this. So, status LED pin. This for the and we'll get rid of all this junk for now. Don't need that for now. All right, Floyd. Status init. Yeah. Yeah, go and do that. We're just going to call that LED. LED. And let's just do that. LED pin. Status. No, let's start the bottom. Here you. All right. Then LED pin. Mm. We'll need that there. It's going to be here. Mm-hmm. Mm-hmm. Then okay. Then if we go over here, Right. All right. Mm, Uh, that is IO4. I think we just put 4. And I think that will work. I may be wrong. Let's build and see if it pukes its guts out. Oh. Wow. Helps if and of course you're mad at me for something. Let's see what you're mad at me. ADF target. Wait, what? All right, let's trash the build. All right. See if that was an artifact. That was interesting. All right, so this builds. I'm gonna get my camera going. Right. Well, with any luck, when we upload this to the system, the status LED will actually turn off. That's what I'm hoping for now. Get that. That way it'll be an indication that we've got core functionality working, and then we'll have to figure out all our flags and how we want to push things in. But I definitely want to get the status started to kind of get the framework going. Because we can throw in like a fault status for the limit switches being disconnected. We could also put in checks really for the travel. If it takes too long to travel from one end to the other, could indicate an error. We could basically create a status flag for that if we really wanted to. That'd be a matter of just kind of timing how long it takes for it to traverse from one end to the other. The timer would reset, each limit switch. All right, so now we got something broken. Let's see what's broken. All right. Jeez Louise. Come on. Okay. Oh, I bet you I knew I did wrong. I've got, my goodness. GPI mode output. Yeah, I knew. I knew I did something wrong there. My brain's not in with it. My brain's not with it today. I apologize. Because then we can isolate this. That way it can handle LED flashing or indicating without interfering with the main code. All right. So why did you fail? Where are you at? Why are you failing on that? Or random. IDF target. Wait, what? All right, let me go over to here. See. ESP. Oh, 5.3. All right. Why are you mad? 78,162. Okay. I swear, every time I go to do something in VS Code, it acts different every time. Every time. Oh. And I have no idea why. I swear half the time of doing anything is fighting the fighting VS Code to get things working right to program it in the first place. Ugh. Yeah, I swear sometimes at work half the time spent doing anything is fighting with VS Code. Just getting it to work. Trying to troubleshoot messages when you just used it the day before. I literally have not touched VS Code since our last video or last stream. Nothing should have changed. Nothing. This is baffling. It's baffling. In fact, I haven't touched the computer that it sits on in all that time. It's like cables behind a desk. You just leave them alone and they just get all contorted on their own. No effort. They just do their own thing. Ugh, that's annoying, I tell you. Just make it stop. Just work. Why are you failing now? Is there any red up here other than it failed? Okay. Put that back. Let's go back to 70 something. Let's try that. Oh, undefined reference. Okay. Jeez. Undefined reference to status. All right. Maybe I don't need this. Let's get rid of this. Let's get rid of this crap. Maybe we don't need that. Oh. Let's do this here. Status LED pen. We don't need that here. We don't need this. Just tired. And then status here. Let's grab status LED pin. What we do is we get that out of here. See if it peeks its guts out. Oh my God. Let's see. Okay, we should go flash it. All right. Setting, okay. Let's go here. All right, with any luck, when I reboot the board, turn that off. Maybe we'll see that better. the red LED will go off. Yeah, okay. So that means we're now in control of the red LED pin, and it won't just be hanging out doing whatever it wants to do. So for reference, now that I'm moving some stuff out of my way, this guy right here, this breakout board, this is the DRV8825 chip breakout board you can get on Amazon for the same stepper driver that I'm using here. This is what kind of spawned this whole project. Just setting this up, because you've got to put jumper wires for every control and every functionality. You got to set up a big bulk capacitor for the 24 volt line for the stepper motor. For the initial kick surge, basically the power surge it draws when it first starts. You got to put that in there, and it becomes a whole mess of wires. Maybe one of these days I'll set one of these up just to actually show you what it looks like, and it's a mess. And to work with a stepper, that's why I just decided to do this project, because I usually do it with an ESP32, this driver. This has everything all in one. I don't have to mess with it. No muss, no fuss. I have a singular source power supply. Don't have to worry about tying grounds together. Plus, this gives me all this extra functionality, the RS-45, the FTDI interface, plus inputs that I can actually control. So this solves a lot of my problems. And I was also thinking about designing a similar project, but built on a pick. Because I like using picks, and they have a lot of similar functionality. In fact, I have driven these stepper motors with a pick, using its PWM system. So I wouldn't be opposed to doing one of these projects built around a pick, to give choices and options. So I will consider that in the future. Maybe once I get the ESP32 version done. And I might just do that mainly for me, but I'll maybe make it another video series. We'll go with pick, and kind of keep a similar format board and size and layout, and have a lot of the same functionality in here. We'll see. So now we've got the status. We know we have it in there. I kind of want to start getting a integrator for start integrating like the non-volatile memory, and then be able to incorporate the cycle count into there. So, mind you, so it's kind of interesting. Is we could set up the non-volatile system. We should be able to, based on the example I've seen. Set it up, and then push data into it, I guess. Or it doesn't take much to use it. It's fine, because that's what we'll do, is we'll put it and we'll use the cycle counter as an example. All right, so we're going to create a new folder. I want to get that kind of incorporated, because I want to be able to kind of start working some other stuff together. Because the system status and the NVM storage, or NVS, non-volatile storage, I want to be able to query via the RS-45. NVS. System. All right. So C. Paste file. To rename that. System. Make sure it's in here. Might have to throw in requires maybe. Oh, we might need this. Don't know. We might need the other one, NVS Flash. I'm not sure. Maybe unnecessary, but we'll clean that up and fix it as we need to. All right. Basic. I should just like create an empty one. Just copy and paste it. All right. All right. So, we'll use the GPIO again. All right. All right. NVS net. All right. Again, we got to clean all this stuff up. I know we do. All right. We don't need DUART. Get that out of here. We'll make sure we clean all these up over time. Again, it's just the way it's going to work for now. So let's see. We're going to need include include all right. Let's see if it wants to complain and all right. Well, I need 3 RTOS in there, but again, it's stuff I'll go through, clean up, and organize. Right now, it's not going to hurt anything now. NVS init. NVS init. Hello. Slash system /h. All right. I guess right now, to make sure we don't have any. Oh, I can't find this issues. Because I know I'm going to have problems. I know it's not going to build good. Yeah, okay, so it's building. It built good. All right. Well, now, that was not expected. Not expected at all. Since in here we're going to go and use the non-volatile storage to actually store the data, we might as well go ahead and use it to do all the counting and stuff in the NVS. So let's go ahead and we're going to go and pull that in here. Because then we can also use the NVS system to store the error flag for, in case the power down or something, we can use it to clear it. So let's go ahead. Let's do this. Oops. All right. Make sure it's not going to complain, because sometimes it doesn't complain until you actually go to do something with it. All right, so where are you mad at? Where are you mad? I knew you were going to be mad at something. NVS init. NVS system. Okay, unrefined NVS init. It's a void. It's a void, because it's not going to return anything. NVS system. Did I spell NVS system wrong? Okay, is that NVS system.h? It's obviously not complaining, so I got that right. Include NVS init. Okay. Undefined reference. Main.c84. Wait a minute. Oh no. All right. Build. Why are you doing this to me? Why? Yes, isn't it? Yes. Undefined reference. This is We will initialize NVS. Wow. Yes. All right. NVS and okay, NVS and knit. Again, I gotta clean all that up. NVS and knit. Okay, let's trash the build. That I do not understand. It's there. It's in the header. It's in the source. Do I have something messed up? It was fine until... It's fine. Nothing broken there. Okay, boy, yeah, okay, that's fine. Prototypes, okay, that's fine, all that. I don't understand why you're mad. Oh, failed to resolve component NVS. Okay, all right. Okay, may not need that. Right, let's trash that. Let's try it again. I am so tired of fighting VS Code just to make one or two things work. And that's what it is. It's just a constant battle. Ugh. Come on, please work. That's half of it just praying and begging that the system works. And I've noticed sometimes that these components, these subsystems, don't like being nested in like this. Just build. You were fine until I went to use that in it, and then I was saying just blew up. Here we go. We failed again. Where are you? Include. Okay. NVS flash.h. Okay. Actually, that could be it, but it could also be under. Sometimes the SDK needs to be configured for the system you're using. Let me see here. Come on. All right. Let's search here. Hello. Legacy. Oh, different data type. Okay. All right, so I don't need to do any of that. ESP32 IDF. Oh, requires. That might do it. I might have to put that in quotes. Because if we could get this built successfully, that's great. Then we can go ahead and kind of figure out how we want to update and read. Come on, just work. Come on. Yeah, thank you. All right. All right. All right. Okay. So system.c. So in the init, we need to. So one of the first things we need to do is actually make sure the space is allocated and the so basically it'll check to see if anything exists, and if it doesn't exist for non-volatile storage space, it'll basically initialize it and kind of like wake it up and say, hey, do something here. All right. All right. So what we're going to do custom parameter. That's going to be up there. That way we don't have to worry about it. That's fine. All right. All right. Okay, so okay. All right. So all right. So what we have to do is basically open and close the memory device for each operation for a write and a read, it looks like. So what we're gonna need to do, because basically we're gonna need to create a all right. So we want the status to be able to read this. That's fine. Actually, that's fine. We can have to figure it all out here. Well, NVS. Error. So basically, we're going to need something to catch any errors if it tries to open or close, open the, so that is an init. So we're going to need to, all right. I need to figure out, okay. So assuming that they don't have to be, well, actually the NVS system's going to handle everything. So we oh, let's see. I got to make sure I'm using that right. Char. I don't know if I'm going to be using that right. I don't typically use. All right. No. Since we're going to be doing fixed things, we don't need to do too many variables. All right. All right. Count. We're going to initialize that variable. So since this is going to do that, we do need access to it here. Next turn. You went 32 cycle count. I don't need to do that here. All right. Here. Since we are pulling the header file over, cycle count. Here. Do kind of initialize it here, because in the NVS init, so cycle count will be equal to 0. Does that build? I don't want to try to suss out all the logic and then have it fail on me because my variables aren't holding. Yeah, where are you on main? You went 32T. I don't know why I did that. There. Let's get initialized up there. Oh. All right. Oh, wait a minute, cycle count. All right. And then I wonder, let me just, let's just, for now. Cycle count. percent LU, comma, mount. So let's see what that does. Okay. Of course. Uh, of course, that's too much data here. I had to do some fancy kung fu here. Oh, that's that. That doesn't do what I want it to do. R45. Okay. Oh. Okay, that's what I had to do. So we're going to come up here. Size of response. Cycle count. Percent LU. Cycle count. And then send that. All right. Part of it is we want to make sure that we are actually communicating here. Drive device manager. Okay, we got the code. Uh, 24. ESP32 load 24. All right. So let's go ahead and shove this over. Flash. Because eventually we won't have it. We'll just be able to kind of use the RS-45 to query it. Say boom. So we're going to reset. So we've got that. Now, let's go ahead and enable. Okay, we need to clean this up here. Okay, that's going to be painful. I'll have to... There we go. Cycle count 1. All right. Boom. Cycle count 2. All right. So we got it going on there. So we got that. 3. All right. So every time it's hitting the limit switch 1, it's incrementing the cycle counter. And then enable. That should not affect the cycle counter. No, it does not. So I was thinking for the longevity of the non-volatile storage, having it basically update the cycle count every 10 cycles to reduce the rates. So if anything happens, at most we lose just 10 cycles. So far as holding steady, I mean, we'll have to figure out our logic for that. But yeah, it's not missing a beat. It's hitting the cycles. It's not doubling any of them. Because again, one of the things is to basically just let this run and just see how durable this TPU printed belt is. So disable it. Go back to here to the code. All right, so we have that. Now, so the cycle count plus plus. So that, who do we want to monitor that? So all right. Oh, what we're going to do cycles is 0. And while 1. So for basically every tick. All right. Does that even work? Or does it not like it? Oh, yeah. Okay. So what we're going to need is probably a task. All right. All right. So that's got to be in the init. Yes. So I got free RTOS. Okay. Why are you mad at me? We'll probably run this video to about 3:30. Only about another 15 more minutes. Why are you upset at that? Oh, probably because I don't have the task defined. It's probably going to be upset. Durr. Yeah, okay. That's why it's upset. I didn't actually have it a task. And the task. Okay, so we can do the while statement in there. Cycles. Cool. So, when we do this init, why are you mad? Oh God, why are you mad at me? Stop it. Oh, I see, because I just added that. I bet you it'll build just fine now. No, why are you mad? Oh, well, void. Works task. Oh, I bet you. I bet you. Maybe. All right. Maybe. I just want you to stop being angry with me. All right, thank you. You're not angry with me anymore. I appreciate that. Okay. So when we init, let's kind of, I don't know. Void. read. I don't know. No, we won't do that. All we're going to do is just store the cycle count in there. I don't think we need anything overly complicated. Oh no, we'll just void read and there we go. So storage. So when it reads, so what is it? NVS error. Storage. So we're just going to read only at my handle. My handle. So we're going to do that. We're going to read. All right. All right. So we need to do error does not equal okay. Error flag. Handler. Okay. Else. Wait a minute. Okay, so I'm reading data, my bad. If NDS. Okay. Or the actual NVS system. Okay. Oh. Oh, no, we don't need. Oh. All right. So we're going to be reading the stored value. Let's see. NVS error equals NVS get I32 I32 my handle. So for that, so it's basically a key value pair. So the key is going to be cycles, and then and I don't know if we can do this. I think I've got cycle count. Maybe I don't know if it's going to complain about this. Because it should be pulling it from here, but okay. All right. Oh. Int. So maybe it just needs, maybe it needs to be an int over here. Int. Which is fine. All right, where are you at? Main.c. Int. Why did I get this at least somewhat functional? All right. Cycle count, okay. Don't know if I need this. I'll hold on to that. I don't know if I'm going to need that. So we have the cycle counts. It's going to come here. And then we're going to okay. So do something. Case ESP NVS found. Found. Okay. Or the cycle value. We're going to break. Default. All right. Default. And then after this, close. All right. Cycle value is not found. Oops. Helps if I have the right punctuation there. Okay. Boom. So these will be like error flags for the status. So we're gonna have to definitely do a lot of back and forthing of this. So NVS read. So when it reads, or when it does this, we're going to want it to, when it inits, we're going to do an NVS read. Because basically when the system powers up and it bootstraps, we're going to want it to read the non-volatile storage, pull the cycle count data out of it, and store it. That way we can just increment it from where it left off. So if the value is not found, so what we can do is over here under the right. I know it's 3:30, but oh, we're so close to oh no. That guy needs to be brought back one. All right. So we're going to write data. Write data. Set I32 handle cycles cycle count. The S mit handle and close. All right. So that works. Okay. So I think what we'll do is if it's not found, we'll basically assume that it's 0. Hopefully gets set to 0. So all right, here's what we're going to try to do. Count equals was 10 and VS right. Let's see if it doesn't like that. Okay, that's cycle count. Cycle count plus 10. So this should start off as, okay, let's flash it. So it should start off as 0. All right. Okay. Or it'll be, all right. So why are you not? Why are you not working? So there's an error. The system is locked or something. It's hanging up for some reason. Oh, let's monitor. Why are you upset? No, you're not upset here. Okay. So it was fine until like here. In the world, why are you stopped? Let's have it right that. So even though it's not acting like it's messed up, it's like it's. Okay, that is a weird problem. Slash you. Okay, let's reset. What in the world are you upset about? We know the RS-45 is working. Why isn't the stepper driver working? Oh, system problems. It's hanging up for some reason. Yeah, it should be closing. Let's take this out of the equation. Let's not even have it read right now. Why are you not working, you goofy little thing? Yeah, I'm gonna be finishing here in a minute. I'm just be ending the video, the stream soon. It's just now I'm getting annoyed. Okay. For some reason it wants to not work. All right. Let's not initialize this NVS system. Let's pull that out of the mix. Because if it works without the NVS system, it's something I have to go through and figure out what I broke. That should reset. Perfect. Okay, so something about the non-volatile storage system is broken, and I need to figure it out. And we will wait till tomorrow's video to do that, because sometimes sitting on it will give me a chance to think it over and just process what could be wrong. So thank you for hanging out and checking out the video. We really appreciate it. And we'll see you in the next one where we try to figure out where I broke the non-volatile memory system. Have a good evening, good afternoon, and see you next time.